Hi everyone, good day. This is my first video. Yeah, as you can see in the display, we are talking about load cell simulator or load cell calibrators. Okay, just for the background for this video, as you know, load cells generating millivolt, yeah, to the junction box, and from the junction box we'll send the signal millivolt to load cell indicator, and the indicator will translate the millivolt to the wake based on your needs. Yeah, so to do load cell simulation or calibration, yeah, you need some equipment that to help you to make sure the jobs done in proper way. In this case, we call it as electronic calibration, yeah, for the load cell. So the equipment you need for this first equipment that really useful, yeah, is load cells simulator itself, yeah, to generate the millivolt. Yeah, this is the equipment. As you can see, it's made by Calibration, yeah, with model load cell 2. I choose this one because the excitation voltage that can be afforded by this equipments up to 15 volt, yeah, up to 15 volts. Yeah, okay. You can get it from RS components. Yeah, this Calibration made in UK. Yeah, this equipment really sophisticated ones. I recommend you to use this, and the price is about 1,800 Singapore dollars. Yeah, okay. The second things that you need, yeah, of course, you need multi-testers made by Sanwa, yeah, yeah, and make sure that the model you choose can read millivolt. This model is PC710, yeah. This also really sophisticated ones. I like this product. Yeah, okay. The third things you need, yeah, we call it as junction box. Some of people saying that this summing box, yeah, it's a junction box made by Fixtor. Yeah, as you can see here, there are 4 junctions, so it means it can afford until 4 load cell. Load cell 1 from here, 2 here, 3 here, 4 here, and this channel here will be connected to load cell indicators. Yeah, and bear in mind that junction box or summing box will not sum all the voltage. Yeah, let's say for examples, this load cell generate 4 millivolt. Yeah, this 4 millivolt, 4 millivolt, 4 millivolt. It doesn't mean that this will generate 14 millivolt. No, they will find some smaller one, and you can adjust. They call it a cornering. Yeah, you can adjust, and this will go to load cell indicators. Okay, and then the price of this is about 200 US dollar. Yeah, this also around 250 US dollars. Okay, and then you need a box. They call it as load cell display or load cell indicators. These indicators or display made by CAS with model CL502A, made in Korea. Quite sophisticated one. I like this also. And from the rear side you can see so power cords, power button switch, and then some here the output you may need. You can read in the user manual the function of these output channels. And this ones is plug that connect from junction box to here, and then inside it there is converters from analog to digitals and etc., and logic gate and etc. inside, and the millivolt will be translated to the wake that you really need. Okay, and then you need some cables. Yeah, these cables come together with this Kellogg. Yeah, and this is the Kellogg box. Yeah, it's the case. Yeah, it's a very nice one. Okay, bear in your mind also that that there is no standards that's mentioning the colors of the load cells. You know, in the load cell there is sometimes 4 wires, 6 wires, and the colors of the wires from the load cells is not similar to other manufacturers. There is no standard at all, so you have to be carefully read the user manual of the load cell, the user manual of the load cell indicators. Yeah, and then you have to match what is the excitation voltage, what is the signal, and what is the sensing, and sometimes what is the number for the seal. Yeah, the cable seal. Okay, I have a sample here, the user manual of the load cell indicators made by CAS. You can download from their official website. As you can see, pin number there, yeah, and the colors, yeah, and it's really different to other indicator, of course. Yeah, so be careful about the colors, because my experience showing that I wrongly accidentally connect the wrong colors, and the reading is not correct. Yeah. Okay, just as a background of this video here, why do we need this load cell simulator or calibrator? Of course, the first thing in your mind that we need this also to calibrate the reading of the load cell indicator, how consistent the reading of load cell indicators. If you increase the voltage or millivolts of these Kellogg's, yeah, how is the correlation between this millivolt output from this Kellogg and the reading from the load cell indicators? That's the first thing. The second things, yeah, I would like to give you an example. Yeah. Let's say you build a system. Let's say the system is weighing systems, like a vessel, yeah, above the grounds, and the vessel you use 3 load cells, for example. Okay, this vessel is with capacity, maximum capacity, let's say 10 tons. Yeah. You install the load cell there and etc., and you have to do the on-field calibrations. Maybe it's very hard to have 20% of the loads of the maximum capacity. In this example is let's say 20% of the 10 tons or 2 tons. Yeah, it's very difficult for you to find a load, for 2 tons on field. So maybe you would like to perform let's say electronic calibrations, so that is why you need this. Okay, for example, you have a 3 load cell to measure 10 tons, and 1 load cell, let's say, generate 2 millivolt per volt, and you use an indicator that excitations are voltage 10 volt, so it means 3 load cells, at 10 tons at the maximum weight, will send a voltage to the summing box, 1/3 of its capacity. So let's say you use a load cell with 5 ton capacity, and then multiply by 3 will be 15 tons, and your maximum vessel load 10 tons, you design it 10 tons, and the load cells can generate 2 millivolt per volt. So by regression and etc., you can make on-field calibration. You don't connect the load cell to the junction box, you don't connect it to the junction box, but you connect this to the junction box, and you make a simple calculation. You can search in the internet how to calculate it and generate the millivolt that's sourcing by this equipment to the junction box and read by these load cell indicators. And then you can do a verification by maybe by actual load, how it mechanically behave, because although you do this electronic calibrations, it doesn't mean it will absorb or represent the mechanical behavior of the system. There is no correlation at all, so you have to be careful to do that. You have to make sure that no overhang or no other loads to the system, no things that maybe obstruct the load cells, and maybe piping, etc. You can see in the user manuals in the internet so many of how to make weighing systems with mechanically correct. So this is the video that explain you the load cell simulator or calibrator equipment that you need. I'm now doing these presentations in using slides, how to make it in proper way, in good explanations. Also, my second video will explain you how to set up the system to do this electronic calibrations or simulator or calibrator use by help of this scallop. I recommend you to use this scallop. Quite sophisticated. I already tested so many times. It's good. Okay, that's all for now. Thank you very much for your times. I hope this helpful and useful for you. Bye bye.